Okay, so we're on to our second session of 3 today. The first speaker in this session is Duncan Bees, who's the Director of Technical Programs for the OpenHW Group and the Eclipse Foundation. Duncan manages the open source process for open hardware and works with project teams across the open hardware ecosystem. And the topic of Duncan's talk is Introduction to the Open Hardware Group CORE-V Ecosystem and the CORE-V-MCU DevKit. So, Duncan, over to you.
Hello, I'm very happy to be speaking to the RT-Thread Developers Conference in 2023. My name is Duncan Bees. I'm the Director of Technical Programs for OpenHW Group, and it's been really nice to work recently with RT-Thread and some of our members who are really interested in supporting RT-Thread on our CORE-V family of embedded devices. So I'm going to tell you a little bit about OpenHW Group, what our activities are all about, and then I'll focus towards the later part of the presentation on our CORE-V-MCU and a related project, the CORE-V DevKit. So these are an embedded chip and a development board that are targeted very much to put the open source processor core technology in the hands of embedded developers. So we're very excited about those developments, and they're very close to being released. So I'll come back to those a little bit later in the presentation. So I'll start off with an overview. OpenHW Group is a not-for-profit corporation. We're registered in Canada, but we work with members from around the globe, including all types of players in the RISC-V ecosystem, big and small companies. Our membership is shown on the slide. It's quite wide. It's growing. So we have a range of companies from processor core development companies to systems companies, software companies, really all the types of participants you'd expect to see in an open source ecosystem focused on building a processor core ecosystem for RISC-V. We also have a really key involvement from many leading universities and academic institutes who have brought leading technologies such as processor core architectures, and they have developed those technologies for academic results, but moving them into open hardware and having collaborative projects with industrial partners has enabled us to bring those academic results up to industrial quality and industrial readiness for adoption. So it's a real win-win. Our partners are companies and organizations that we work with to deliver our open source results in many ways. So how are we organized? We are organized in terms of a board of directors who directs the work, and all of our work is member driven. And our board of directors are platinum members in OpenHW Group. All of the members in OpenHW Group participate in the technical working group. So the technical working group is like an engineering organization and a silicon company, has different focus areas, and those are reflected in our task groups. Cores, verification, software, hardware, and we have started a new task group recently that we're extremely excited about. This is the safety and security task group. The safety and security task group is going to focus, as you'd imagine, on functional safety requirements as well as security requirements, and looking at the two jointly and hand in hand that would influence next generation features for processor cores as well as system level requirements. So we'll be developing IP to support functional safety and security. So in addition to our technical groups, We have marketing, of course, and we have regional focus groups, Asia and Europe focused, that are looking at regional ecosystem requirements. I had the pleasure to work with many of the Asian companies closely in the Asia Working Group, and we've made some good results looking at the roadmap of open source work surrounding RISC-V that's happening in both China and other Asian countries, and then kind of comparing that to the work that we have done already in Open Hardware Group. And we're looking for opportunities and areas for contribution for the Asian members, and looking again to build that kind of win-win between and among all the global partners. The Europe Working Group is very active as well, and they have they are working on a major European project called Tristan, which is again developing and furthering families of IP for these open source processors. Okay, how do our members come together to select projects and to really to manage those projects? We have a methodology which is a simple and light methodology, similar to what you'd find in any engineering organization, where we plan and propose projects, and members review the projects and decide on which ones should go forward. So we've coupled that kind of silicon engineering methodology together with leading open source processes under the Eclipse development process developed by the Eclipse Foundation, our open source partner. And it's a real win-win there. We publish all of our work under permissive open source licenses, or in some cases, we upstream software results to other projects. But the work that we publish and release is under Apache 2.0, Solderpad 2.1, or the Eclipse public license. So the gates that we go through, you can see we have very simple gates, but those gates really allow us to provide checkpoints and feedback, as we have more than 25 projects now in flight. And so this is a way for the technical working group to provide assistance and comments to the different project teams as they go through the project development. You'll see here a picture of our cores that are in development. And we have a wide family of cores. As I mentioned before, many of these cores originated as academic projects, either through ETH Zurich, Simon Fraser University, Harvey Mudd University, Oklahoma State University. So there's a wide network of academic partners, and there are others besides those that I mentioned as well, that have seeded this work. And our work in open hardware is to take that work through, typically up to TRL5, although in some cases we have projects that are aimed at TRL4. The difference being, in our view, that TRL5 is a fully verified core that's ready for industrial adoption. So in some cases we have TRL4 targets, but those would be targets on the way to bringing the cores up to TRL5. And you can see where each of the projects are. Just at a high level, we have the CVA6 family of 6-stage single issue in order application class, so processor cores that are capable of booting Linux. Working very hard on CVA6. There are multiple configurations, both 32 and 64-bit versions of the CVA6 core that are planned. On the milestone chart, you saw one of the initial targets, but ultimately the CVA6 family is targeting TRL5. CVA5, which is an FPGA targeted soft core. CV-Wally, which is coming out of Oklahoma State and Harvey Mudd University, which is a family of cores that are optimized for educational purposes. And there are some very compelling industry textbooks that are being written around using CV-Wally as a demonstration and pedagogical vehicle. CV4 family is where a lot of our work is focused. That's the family of cores that have led to the CORE-V-MCU, as well as other variants, the security, the E40S variant, among them, and several others that you'll see on the milestone page. Any information, anytime that you'd like some more information on the materials here, I'm going pretty fast, please don't be afraid to get in contact with us to find out more, or visit our GitHub, of course, page. And then we have the CVE2 family, or CVE2 core of which is a area and power efficient two-stage microcontroller. This is really targeted at cases where you might have an embedded state machine that you're replacing with a very efficient microcontroller. And that is also in heavy development phase right now. I don't have time to go into the verification, but just to say that our verification test bench and methodology, which we call CORE-V-Verif, is really a cornerstone of the work. And as it's applied into all of the different cores, it provides a common methodology and a set of tools and procedures to bring these cores up through verification up to TRL5. We also have many forward-looking verification projects underway in our verification task group. So again, if that is appealing to you, please get involved and help drive those projects forward. Okay, so I'd like to talk about our embedded work, particularly the CORE-V-MCU and the related hardware and software ecosystem elements that are being developed around the MCU. So what is the MCU? The MCU is an integration. It's a system on a chip of integrating the E40P V1 processor core, which was released in 2021. That processor core is a 32-bit four-stage core, optimized for power efficient and area efficient applications. And integrated together with that processor core are a number of peripherals. So standard peripherals, UARTs, QSPI, I2C, SDIO, a number of IO peripherals, integrated together also with an eFPGA, enhanced FPGA fabric, supplied by QuickLogic, one of our industrial members. The MCU is being fabricated now at Global Foundries in 22FDX. So we're super excited about that. That's our first tape out. And I believe we taped out about a week and a half ago. The MCU itself won't be a product, but it will be available on the DevKit. We're putting a lot of focus and energy right now onto finalizing the steps like packaging, as well as the software support around the DevKit and the final design of the DevKit to enable embedded developers to get their hands on this and evaluate this open source RISC-V core, its performance, and do some software development on a real board. So what does the DevKit itself look like? So the DevKit includes the MCU, includes onboard debugging capabilities, USB-C, JTAG. It includes an IoT Express Link module. So this is a Wi-Fi module that builds in the Amazon Express Link API to allow it to interconnect with IoT services in the Amazon cloud. It includes microbus for easy plug-in of clickboards that support a very wide variety of peripheral functions. It also includes a temperature sensor, camera. So altogether, we think it's quite a nice little package. There's a system diagram of the board. This shows you how things interconnect. You have the microbus for integration of click modules. You have the debug side. You have a flash memory for storing program code. And then you have the Express Link IoT integration together with the camera for demo applications. And then inside the MCU, again, we have all of our components and peripherals that I mentioned previously together with the QuickLink eFPGA. So before I talk about the software support for the DevKit, I'll just give you a brief introduction to the software task group. That is a group chaired by Jeremy Bennett from Embecosm, and he's been having the support of Alibaba as vice chair for a long time now. My understanding is that Alibaba is moving on from that role, and so we have an open position as vice chair. But the software task group develops the tool chains and defines the integration into the Core-V family of cores for things like compilers, IDEs, operating systems, and hardware abstraction layers, tying it all together into an SDK. And so the SDK for the MCU and the DevKit is really our lead project on the software side to integrate all of those features together. Obviously, the SDK allows host PC-based development on Linux or Windows of an Eclipse-based IDE and connecting into the DevKit board or the FPGA emulation board for the Core-V MCU. So some of the components, the Core-V IDE, which is developed as an open source variant of an Ashling IDE based on the Eclipse IDE, including integrating the GCC toolchain, OpenOCD debug, ready to run code examples, and getting started guides. So it's really an integration of a lot of work and delivered through an IDE package or an SDK package. Some of the on-chip components, again, so example applications, test applications like Blinky, support for bare metal development or FreeRTOS, and common driver layer, which is being built from the FreeRTOS Common I/O technology that's developed at Amazon. And some of the future extensions here are worth noting. So there's a lot of interest in moving forward with RT Thread, and there has been an initial RT Thread port to the Core-V MCU in emulation. I think I have a slide to say a little bit more about that. And then also on the embedded FPGA or the eFPGA fabric, we are working to develop open source tool flow to support programmability of that eFPGA so that people who are looking more at machine learning or AI applications can use that open source tool flow and follow some example programs that we will be integrating and hopefully develop some very interesting acceleration of vision processing applications using that eFPGA fabric. So as I said on RT Thread, so far there has been done some substantial work to port RT Thread in conjunction with Institute of Software at the Chinese Academy of Sciences and the RT Thread Consortium. And we are in discussion right now at the project level in OpenHW Group as to how the members can integrate this as an option with FreeRTOS within the SDK context. So that's a discussion that's ongoing, and if anybody would like to get involved in that, that would be certainly more than welcome within our technical working groups. So just a note, this is a picture of the basically the prototype of the DevKit, which is built on the Nexus A7 FPGA board, and we are also using other FPGA boards, the Genesis card as well, Genesis 2 card for prototyping of CVA6 processor applications, as well as more advanced MCU type architectures. So there's lots of work, but we already fully support the Core-V MCU on the FPGA platform now, and you can buy that board and install the SDK and the MCU through downloads from the OpenHW website. A note on some future-looking, I guess, embedded applications and extensions to the MCU. We're building a trusted MCU ASIC as well, and that will support a secure boot capability. And we have several OpenHW members driving that work: Crypto Quantique, Low Power Futures, Datum, as well as, again, collaboration with Global Foundries. and that will be a key topic for our new safety and security task group. We have a very interesting project that is combining a vector coprocessor, which has been developed at Polytechnique in Montreal, together with the CVA6 application processor. And this is I guess we'd say a test chip, but it will be evaluating a very interesting 4-tile architecture with CVA6, the processor, and the vector coprocessor, also called ERA. And another related variant, again, there is a family history across many of these chips that are being developed. This one is the Vision APU, and again, it's a different combination of CVA6 and the vector coprocessor, but it's also integrating one of the 32-bit cores as the MCU, the CORE-V MCU that I've already showed you. And this is again targeted as a prototype open source project that will be capable of some AI applications, where the low power domain will wake up the high power domain in cases of need for heavy duty processing. So again, we have many projects at OpenHW Group that are tying together all of these disparate elements, the processor cores, the software families, and the embedded architectures. And we're building an ecosystem model. And as I said already, we're extending the support from FreeRTOS as well. We're considering to extend the support from FreeRTOS to RT-Thread. We support Linux on several of the cores. And so we have a real ecosystem model that we're building together with our members. That's what I wanted to show you today. Thank you very much for your attention. We've as you can see, we're integrating a number of cores from this small and simple to the larger and more proficient. We have a number of system on chips in development. We have a full set of software support behind this, and we have partnership with all the elements in the ecosystem, including the foundries. So we're building what we think of as truly an open source ecosystem. We'd be happy for any people who would like to have any more information or are considering to get involved. Please do contact us either through our website or the email info@openhardwaregroup.org, or you can contact us on Twitter as well, or LinkedIn. So we'd like to hear from you, and thank you very much for your attention today.